Alright, if we look at this, it tells us to let alpha be inverse sine x and beta be inverse inverse tan of x. So that means that sine alpha, if I just rearrange it, equals x, and tan beta equals x. So when it says cos alpha plus beta, I know that's cos alpha cos beta minus sine alpha sine beta. But I don't know these things separately. But can I tell from these two things here? Yes, I can. So if I do an alpha here, sine alpha is some old hag, so it would be x over 1, and tan beta, let's do another one with a beta, their old h would be that. So the third side using Pythagoras would be x squared plus 1 for that one. On this one, it would be the square root of 1 minus x squared. So now I can find cos alpha from here. Can't always hide. So that's going to be square root 1 minus x squared on 1. What else do I need? I need sine alpha, which I've got because that's up here. Sine alpha is x. I need cos beta. Can't always hide. So there's cos beta. And I need sine beta. Some old hags. Alright, there we go. So using all those and subbing them in, let's see, cos alpha is square root 1 minus x squared. Cos beta is 1 over x squared plus 1, root x squared plus 1. Then we've got minus, oops, I haven't left myself any room, sine alpha and sine beta, which are here. So I'm going to rub this one out because I don't need that one now. And hopefully fit this in. So sine alpha being x on root x squared plus 1 times sine beta, oops, sine alpha was not that, sine alpha was up here, which is just x, oopsie daisies, just x, and sine beta being x, so I'll just put x squared on root x squared plus 1, so I don't need that bit there. Alright, so you can see both these terms can have a common denominator of x squared plus 1. If I do that, what have I got? So my first term is root 1 minus x squared, and my second term is minus x squared, which is what we were looking for, so that's all good. Alright, then it says to show, so if alpha plus beta is pi on 2, so that means cos, up here, alpha plus beta would be cos pi on 2. Now cos pi on 2, we know the cos curve goes like that, that's at pi, so this is at pi on 2, so we know it equals 0. So if that's the case, then this is going to equal 0. So let's make that equal to 0. So when I multiply this across here, no, I multiply both sides by that, I get 0 on the right hand side still. So I've just got the square root of 1 minus x squared has to equal 0. So square root of 1 minus x squared equals x squared. If I square both sides, I get this. If I put everything on this side, I've got a kind of a quadratic in x squared, So if I want to solve for x squared, so it's like going m squared plus m minus 1, where m is x squared. And so now I'm solving for m. Okay? So same thing, x squared equals, so I can use the quadratic formula, negative b, so negative 1, plus minus square root of b squared, so 1 squared, minus 4 times a, which is 1, times c, which is negative 1, so that's just going to be plus 4. On to a being 1, 2 times 1 is 2. So you can see there we've got negative 1 plus or minus square root 5 on 2. But since we know that x squared is always greater than 0, that would mean x squared would have to be the positive version here, which is that version. So we have shown that that is true. If I just rearrange it, it will now look like that. There we go.